right, so today we're looking at seasonal indices. So seasonal indices is another way, you know how we can look at time series, but when we have seasonality in that time series. So we looked at other ways to smooth the techniques. So we had median smoothing and mean smoothing. Now seasonal indices is another way of smoothing out the data, but just a little bit different. And so what we do, so when we have time series data shows a seasonal trend, so that means we see something happening every time in the same period. So it could be, if we have 4 quarters, it could be, you know, we're seeing every winter it does something, or every quarter, you know, 4th quarter or something. If we have days of the week, so that means we'd have 7 days, we could see something happening every day on day 6 every day. That would be seasonality. So what we do is we understand that we have peaks or maybe drops on the same day every time, or the same season, we'll call it. And so what we're going to do is we're going to de-seasonalize the data. So we're trying to take away that's peaking or dropping every day, and we want to see the overall trend, and that's where we can do that by de-seasonalizing the data. So to de-seasonalize the data, we need to find the seasonal indices, and what they are, they tell us how a particular season compares to the average. So say when I talked about, say, jumper sales, we would see the winter season is above average, yeah, because we're colder, people buy more of that. We'll probably see the summer season being below average, and that's what a seasonal index tells us. It tells us whether it's above or below average. So when we talk about the seasonal indices, it will be a number, and if you have a number, if a seasonal index is 1, it means it is average. It's exactly the average. And you'll see the other ones. So here too, it says the sum of the seasonal indices, so here, equals the number, will add up. So if you add up all the seasonal indices of your data, it will equal the number of seasons. So there's an example there. So if we were looking at all the months of the year, and we saw that every July something was happening, so we said there's seasonality. So the months are the seasons. So when you add up all the seasonal indices of all those months, it will equal 12, okay? If your seasonal indices, if you've got it, the seasons are quarters, then you'll see the seasonal indices will add up to 4. And we'll see them in our examples later on in a minute. So seasonal indices tell us how a particular season compares to the average season. So here's a little example. If you had a seasonal index of 1.2, remember 1 is average, so that tells me what that season is 20% above average. Okay, if we have a seasonal index of 0.9, you are under number 1, so remember 1 is average. How much under are you? You're 10%. So we like to say we're 10% below. So if you look at that, it's like saying 1 minus 0.9, that gives us 0.1, which is why we've indicated that to be 10%, okay? How much lower than 1 is it? It's 10% lower. Okay, so suppose the seasonal indices for electricity usage in Essie's home are shown in the table. So this is her seasonal index. So her usage for her over her electricity use. So for summer, she has a 1.16 seasonal index. So that means she's 16% above average. In autumn, she's 0.94. So she's 6% below because she's under the 1. But here we've got some questions asking us for it. It says, question A, what does the seasonal index for winter tell us? So if we said, all right, well, winter equaled 1.26, so make sure you copy. So that tells us that winter is 26 above average. So her usage of electricity in winter is 26% above the average, her average. So then in B, if we're looking at, it says to look at the seasonal index for spring. So in spring, the seasonal index is 0.64. So that's going to be below average. And how much below is it? If you're 100, how much below? Yeah, 36% below average. Okay. So this is just us interpreting a seasonal index. They've given us a seasonal index and they're saying interpret or tell me, what does that tell me? Okay, so using the seasonal indices to seasonally adjust the time series. So we've got this time series, we see that it is got seasonality in it. Now we want to deseasonalize all those values. So, and we want to make sure, so we want to deseasonalize it so that we can see a more overall trend. Okay, so we can use the seasonal indices. So those seasonal index are used to deseasonalize the actual values. So you would have had these time series and the actual values would be the Y's, the Y values, or the response variables. And we want to deseasonalize. So you can see in the formula for deseasonalized figure, you take the actual. So if you need to write a little note, that's the Y values, yeah, at a particular time, a season. And then we divide it by the seasonal index. So you'll often see me, I'm just going to write I'll often write DS for deseasonalize, just because when we're writing the formula. Okay, so that's how we would deseasonalize. So I could deseasonalize all the figures. So what I'm going to do is I'm going to take summer's actual figure, and I'll divide it by summer's seasonal index that we've calculated or whatever. And then we'll get this deseasonalized value. It'll make sense when we do a few. So reseasonalize the data. That's when you might want to write what this is. It's going backwards. So you're going backwards. It means you're going from the deseasonalized value, you're going back to the actual. Okay, so it's when you want to find the actual value. You're reseasonalizing it. So they might tell you, here's the deseasonalized value, what was the actual, and here's the formula. It's just a rearrangement, but we can just use this formula if we like, okay? All right. Okay, so here we have the seasonal indices for cold drink sales for Imogen's kiosk are shown. So they've told me the seasonal indices here. So which season, I'm just going to test you, which season is 13% above average? Spring. Good, that's exactly right. Spring is... Oh. So let's go through this one. It says if the actual sales, so I'm doing A, if the actual sales of cold drinks for summer is 21,653, what is the deseasonalized value for that? So let's have a look at this. We're going to have a look at A. So they want me to find the deseasonalized value. So I always write the formula out. So deseasonalized is actual over seasonal index. Because sometimes if you write that, they might not so obviously tell you what, the actual is. They might not actually use that word actual, but that will help you. So we said 21,653 was the actual. Now I'm talking about summer, so I have to use summer's seasonal index. So that's divided by 1.75. And you'll see that we get 1,2,373. So if summer, just so you're checking your work, is summer, if you look at the seasonal index, is summer above average or below average? Above. It's above. So because summer is is above average, when you deseasonalize, the number should go lower because we're trying to smooth it out. We're trying to bring it back to what average is normally, okay? So summer is above average, so the deseasonalized value should be lower. Okay, so which it is, okay? We can see that. All right, so then it asked us, it tells us in part B, it says if the deseasonalized value for cold drinks last spring totaled to this, so this was the deseasonalized value. What was the actual? Okay, for that sales period. So we would go use that reseasonalizing formula. So where we said actual equaled, and I'm just going to call it the deseasonalized value times. I often write seasonal index as just SI as well, so I don't have to keep writing it out. So then we can see the deseasonalized, they told me that. And spring's seasonal index was 1.13. So was spring above average or below average? Above. So when wait a minute. Okay, so when I times this, because I've got the deseasonalized value, the value should go up because we reduced it because it was when we deseasonalized it. So we end up with 12283. Okay? Okay, so going on. So consider the table which gives the seasonal indices for heater sales at a discount store. What percentage should the sales in summer be increased or decreased in order to deseasonalize the value? Okay, so these are the type of questions, they get a little bit trickier, and they're testing your actual understanding of what's going on. So what happens is we want to see how does the number change when we deseasonalize that and when we deseasonalize the data for summer. So what you do, if you think about it, if we write the formula for deseasonalize, so remember deseasonalize would be actual divided by seasonal index. Okay, we don't actually have an actual, but they're just asking me how would it change. So, and they want me to talk in a percentage. So what I'm doing is I'm making up this actual, and I'm making it as 100. So write that down, write that somewhere that we made up the actual of 100. I made it up. Okay, because what I'm going to do is if I deseasonalize 100 using the formula, so we want to deseasonalize this summer number, and I divide it by the summer index, which is 0.65, what we end up is a number of 154. So we started with 100 and we went up to 154. So what happened? How did it increase? It increased by what? 54. And I can say it increased by 54% because I used 100. And so it's a nice number to use, isn't it? Because it's going to tell me straight off. I don't have to change anything, yeah? So I used 100 because it makes it answer it the way I want it. So therefore, so we know how much do we have to increase or decrease. We need to increase, to deseasonalize the value, we need to increase by 54%. Okay, so that's the answer they're looking for. All right, if we look at question B, it's asking a similar thing. What should the percentage, should the sales in winter be? So if we were going to go deseasonalize the winter sales, do we have to increase them or decrease them? If you have a quick look at winter, winter is above average. So what would we think we would need to do? Decrease. So we should be decreasing by a percentage. We're still going to do the same as what we just did then. It's still asking us, and I'm going to show you how we did it. So we're using this made up 100. but now I'm dividing by the winter seasonal index, which was 1.35. And when I do that, I get 74. So I went from 100 to 74. So how much did it decrease by? Decrease by 26. Can you see 100 minus 74? So we decreased by 26%. So the answer would be decrease by 26%. Okay? So it's good to have a think about whether it should increase or decrease, because you may in multi-choice be able to eliminate a lot of answers really quickly. Okay, so now we've looked at seasonal indices and what we can do with them and how we do that. But now we have to know how they are actually calculated. So how do we calculate a seasonal index when we are given data? And so here's our formula that we're going to be using. So this is the big formula for seasonal index. So when you're trying to calculate a seasonal index, you get the value for the season, so what actually happened, and then you divide it by the average over the all seasons. So we'll see what's here. So here's an example. We have Mickey runs a shop and she wishes to determine the quarterly seasonal indices for the number of customers to her shop based on last year's figures, okay, which are shown in the opposite table. So if you look at the formula, I'm going to have to find 4 seasonal index because she's got 4 seasons. But if you look at the formula, it says the value of the season. Sometimes we call that the actual, yeah? And that's along here. We've been given what actually happened here. But then you have to divide by the seasonal average. So if we look here. So I'm going to calculate the seasonal average. And you do that the same way you work out any average. So how do we work out an average normally? You add them all up and you divide by how many there are. So that's what I'm doing here. I'm going to add them all up and I'm going to divide by 4 and I get 923. So this is the seasonal average, 923. So sometimes we might add here season average, an extra column in our thing, or you might see it displayed like that. They'll then tell you what the seasonal average is. So then if I go to find the seasonal index for each of the seasons, so I'm going to do summer. I'll do summer first. So summer was actually 920 and I'm going to divide it by the seasonal average, which is 923. And sorry, this is summer. We're going to get, now I'm going to round to 2 decimal places, and this one ends up being 1.00. Is 920 is very close to 923, isn't it? And do you remember when I said if you're average, you're 1, aren't you? So we're close. So that makes sense. All right. So then if we do the next one, autumn. So I'm just going to do it underneath. So autumn's was actually 1085. And if we divide it by 923, we get it to equal 1.18. Okay, so that is the seasonal index for autumn. If I do the next one, winter, it would be the 1241 divided by 923, and I end up with 1.34. And then the last one, spring, would be 446 divided by 923. And this spring looks very low, so it should have a low, it should be a low seasonal index there. So there is my seasonal index. Now, because I have 4 seasons, if I add these up, these 4 seasons, so when I add up all those seasonal indices, so if I added them all up, you get 4. So because, and you might want to write that, because there are 4 seasons, the seasonal index add up to 4. So that's where you know you've rounded right or you've done it correctly, because you've got it should all add up to 4. Okay, so that was calculating the seasonal index with just one year of data. But what actually happens most of the time is the shop will have a few years of data, and we want to get an overall seasonal index for like the whole set of 3 years. So the way you do that is you have to calculate the seasonal indices individually for each of the years, and then you average those three, like, because we've got 3 years here, we'd average out those 3 seasonal index and get an overall one. So let's go through, we'll go through the data. So we know when we're trying to calculate we're trying to calculate the seasonal index, remember it's going to be actual divided by seasonal average. Okay, so I'm going to create a table that has the seasonal average. I'm just abbreviating it there. That first year is the data we've already done, so I'm going to say it's 923. And so what I've done now is I've added these ones up and I divided by 4, and I got 1028. So I've done that previously to get us ready. And then we divided this one by 4 and we got 1183. So that way I got the seasonal index, seasonal average for every season. So then in summer, we've already done these ones, so I'm just going to pop that one in because it's the same data as what we did before. But I'll do, I'll do one of the other ones. So when in this summer 2, year 2, when I'm trying to find this seasonal index, I'm going to go the summer value, which is 1035. I'm going to divide by the average. So in the year 2, the average is 1208, and I get 1.01. Okay, so that's what we're doing. I'm going to pause it and do a few, and I might describe how I did spring because I've got room there. Okay, so I'm just going to do this last one here and just to help you. So spring's actual value in year 2 was 541. Year 2's seasonal average was 1028. So when I divide those two, I end up with 0.52. Okay, so and then I'm going to go do year 3. So I'm just going to do this last one in the spring. So in the last year or the 3rd year, it was 659 divided by its yearly average, which was 1183, and I get 0.56. Okay, so because it did say to 2 decimal places, so we've done that. So now once you've done this, we need to get the overall average. So the overall average is when we're adding up the 3 seasonal index and then dividing by 3. So let's write that in there. So it would be 1.00 plus 1.01 plus 1.10, and we're going to divide it by 3, and then we would get an answer. So I'm going to pause and do that. Just going to do this last one. So this last one would be all spring's seasonal index added up. So there's the 3 seasonal indices for spring, and I divide it by 3, and I end up with its average is 0.52. So now I've got the overall seasonal indices for this data. So once we've got our data, we've calculated the seasonal indices for them. So, they've just done them there, so hopefully we were right when we wrote them all out, were we? Hopefully. So then they want us to deseasonalize the data, because in the end what you're going to do is you're going to change your time series to be the deseasonalized values, and because this one's quarters, I'll just write the quarters along here, yeah? and we're going to deseasonalize all the values. So you can see this is actually, if you look at it, this is, I'm going to write the quarters in blue, yeah? So this is quarter 1, 2, 3, 4. This would be quarter 5, 6, 7, 8, and this would be quarter 9, 10, 11, and 12. So if you were entering that into when you go along here, you're going to have from quarter 1 up to quarter 12 along your scatter plot axis. Just be realised. But obviously, we need to deseasonalize the values first. And we've put the formula there to remind us. So if we look at, I'm going to do it in green. So summer's deseasonalized value, it actually had 920 their sales in summer, but I've got to divide it by its seasonal index to get the deseasonalized value. So if I do 920 divided by 1.03, I get 893. So that's the deseasonalized value. So if I was plotting this on the thing, on 1, I'd go up to here, and that would be 893 when you're plotting it, yeah? And then obviously you will go through all of them. I'll just do the last one. I will fill them in, but just on the video, I'm just going to do the last one. So the last one is 659. That's what actually happened. Spring's seasonal index was 0.52. So let's see what its seasonal average value was, sorry. And we get 1267 was its deseasonalized. So on number 12 up here, I'm just roughly doing this, it would be 12-1267. That would be more, and then you'll end up with your little values, whatever it happens, okay? And you'll see that's a lot smoother, and you'll see it smooth out, and you can see the overall trend. Looks like her sales are increasing, even though we've got seasonality, yeah? Popped in all those values in there, and as I said, you would then graph the deseasonalized values against the quarter.